Respected Head of the Department, Professor Dr. G. Raju, Dean of Kerala University and MG University, Professor Dr. S. Razia Begum, Professor of the Department of Commerce, Dr. P. N. Harikumar, Professor of the Department and Director of IQAC, Dr. Gabriel Simon Tattin, Associate Professor Dr. Biju T., Assistant Professor Dr. Biju A.V., Lecturers on Contract, Mr. Binu and Ms. Lakshmi, representatives of the Researchers Forum and Alumni Association, and dear participants. Welcome to the 8th day of the webinar series titled Shaping Focused Research, Finding Answers to 10 Questions. The theme for today's session is How to Decide Sample Size and Sampling Technique. The resource person for the day is Dr. P. N. Harikumar, who is currently serving as the Professor of the Department of Commerce, School of Business Management and Legal Studies, University of Kerala. Sir has published an extensive number of research papers in both national and international journals with high impact factor. He has contributed immensely to the academic fraternity and participated and presented papers in several international conferences. Sir, on behalf of the Researchers Forum and the Alumni Association, I'd like to welcome you to today's session. Next, I'd like to welcome all of the faculty members and representatives of the Researchers Forum to today's meeting. Last but not the least, I'd like to welcome all the participants to today's session. All the participants, please note, you're kindly requested to turn off your audio and video till the end of the presentation. If you have any queries, you may post them directly in the chat box and we'll address them later in the question answer session. Without further ado, may I now invite Dr. P. N. Harikumar to take over the session. Over to you, sir.
The most respected Head of the Department and my dear friend Dr. Raju sir, Dean Faculty, Russia teacher, Coordinator of IQAC and the Professor Dr. Simon sir, my friend and the coordinator of this program, Biju T. Again, my friend, Dr. Biju A.V. And the teachers, Lakshmi and Vinu, the research scholars, and other teachers. I'm very happy to see that question. How do I decide the sample size and sampling technique? Normally, this question is asked to the research scholar when he or she present the abstract of the thesis, either in the pre-submission seminar or in the open defense viva voce examination. But majority of the research scholars have not answered that question properly. How did you fix the sample size? Normally, so many formulas are available. But why you apply a particular formula in that situation? No answer. Again, what is your method of sampling? Sometimes someone asks, someone tell, simple random sampling, multi-stage random sampling. Why you apply that particular method for selection of sample from the population? But majority of the research scholars have not answered that question properly. So that is why that particular question is included in the seminar, in the webinar. And we have to answer that question properly. Shall I share my PPT? Biju?
Yes, sir. Please share.
So the question that is very, very relevant in the research scenario, especially in social science research. How do I decide the sample size and sampling technique? So before going to answer that question, I start from the meaning of the research, especially in social science. Simply means search for facts, answers to so many questions, sub-questions, and found a solution to some problems. Problem of research. But in social science, it will be a purposive investigation, organized inquiry. Social science research is basically scientific inquiry. So that is why in social science research design and sampling are the two important stages. So many steps are available in the research process, but these two, research design and sample design, are the two important factors in social science research. But here I want to compare the scientific research and social science research. In scientific research, the outcome will be the scientific truth or natural truth. S2O, two molecules of hydrogen, one molecule of oxygen, that will give water. If you repeat that experiment n number of times, you will get the same output, same outcome. 2 plus 2, 4. That may not be 5, that may not be 3. So the scientific research, the output will be scientific truth or natural truth. Statistically, if you repeat that experiment n number of times, you will get the same output, same research. But social science research is something different from scientific research. In social science research, you have a number of variables related to the research problem. In your research topic, definitely you will find number of variables classified into dependent and independent. One variable is related to another variable, connected to another variable. That variable is again connected to some other variables. So there is a network of relationship, chain of relationship among those variables you identified through literature review. Through literature review, you identify n number of variables classified into dependent and independent and tries to establish some relation. That relation may or may not be true. That is why there is an assumption. That valid assumption is called a hypothesis. So hypothesis is basically the tentative relationship between dependent variable and independent variable, and you have to prove it by testing with appropriate statistical test. For that purpose, you need the data. Data has to be collected from the target population. So in social science, there must be a survey. Whatever be the research design, whether it is descriptive, analytical, empirical, or even exploratory, social science research is purely based on survey. So survey design must be applied by the researcher in social science. If we collect data, study is fully based on secondary data. The collection of secondary data is also a type of survey. So in this context, where to collect the data? Data has been collected from the respondents. And all the members, all the units of study constitute population. So population is very, very important time in sampling. The universe of the units from which the sample is to be selected. All the units, all the members under study relating to a topic constitute population. And sample the segment of the population that is selected for investigation. So sample is a part of the population. Sampling is basically the process of selection of the respondents from the population, and we try to generalize the features of the population through sample study. So two very important terms, population and sample. See, this is the population and this is a sample. So sample is a part of the population. So there are two conditions or assumptions upon which sample have been drawn from the population. The parent population from where the sample have been drawn is normally distributed. That is very, very important condition. When you select sample from the population, this assumption, this condition must be kept in mind. The parent population from where the sample have been drawn is normally distributed. And the sample selected will be true representative of the population. Sample is basically the representative of the population. These two assumptions or conditions upon which we draw sample from the population. Why sample? If we opt a sample study, definitely the cost will be very low. Greater accuracy of the research when we opt a sample study. Speed of data collection and availability of population elements. Theoretically say that sample study has this type of advantages. But when we use census survey, we study all the units in the population. It is flexible at the same time, it is very costly. Again, we will get an idea about type of population. Basically, two types of population we can identify. Finite population, infinite population. Non-population, unknown population. In the case of finite population, value of population parameter can be estimated. In the case of unknown population or infinite population, value of population parameter can be estimated, but it is very difficult. But you remember one thing. What we will do in sample studies statistically, we collect data from sample respondents and analyze it. Then we will get some sample statistic. And this sample statistic will be used for predicting the unknown value of the population parameter. That is what we will do in sample study. And put in another way, we select sample, collects data from the selected sample, analyze it. At the time of analyzing the data from the sample respondents, we have certain values like mean, median, standard deviation, or some other values. Use that value and the findings of sample study for generalizing the characteristics of the population. So that is why there is interpretation of the result of the sample study and generalization. These two steps are involved in the research process. Interpretation of what? Interpretation of the result of the or output of the sample study. What is generalization? Based on the output and interpretation, we generalize the features of the population. So that is why statistically we say that sample statistic must be used for predicting the unknown value of the population parameter. So whether the population is finite or infinite, actually what we will do, we collect data from the sample respondents identified from the population. Then based on the data collected, we analyze it. Definitely we will have certain output, values of the statistic, and that will be used for predicting the unknown value of the population. Again, type of population, homogeneous and heterogeneous. In the population, all the units have certain features, common features. And in the case of heterogeneous population, There are different features associated with the different units included in the population. So homogeneous and heterogeneous. Then theoretically speaking, what is a good sample? Accuracy, precision. Accuracy, the property will be achieved when the sample is representative of the population. Already mentioned, sample is a true representative of the population. Greater accuracy through sample study. Precision, exact representation of the population in a sample is difficult. There happens some error in the result due to sampling fluctuations. These are sampling errors. And precision B means such error is minimum. The sampling error is minimum. Then we will have the precision. And sampling, different sampling techniques. Non-probability sampling and probability sampling. And if the population is finite, definitely we can apply probability sampling. Even though the population is finite, some research scholars apply non-probability sampling. See, in the case of probability sampling, what we will do? We apply the concept of probability at the time of the selection of sample from the population. Probability here means every unit in the population has an equal chance of being included in the sample. At the time of selection of sample from the population, the application of probability concept here means every unit in the population has an equal chance of being included in the sample. That is why we select the sample at random. Then the probability sampling includes simple random sampling, systematic sampling, cluster sampling, stratified random sampling, then double sampling. But in the case of non-probability sampling, the selection of the sample from the population is purely depends on the convenience and judgment and choice of the researcher. There will not be the application of probability concept. But theoretically speaking, if the population is known, if the population is finite, it is better to apply probability sampling because we have the source list in our hand. Again, sampling method is classified under two heads: probability sampling and non-probability sampling. Simple random sampling, cluster sampling, systematic sampling, and stratified random sampling. Non-probability includes convenience sampling, judgment or purposive, snowball and quota. But there is a controversy regarding the application of snowball and quota sampling. The controversy is like this: whether the quota sampling is coming under probability or non-probability. Some of the statisticians clearly stated that quota sampling and snowball sampling is coming under probability sampling methods because in the case of quota sampling and in the case of snowball sampling, the first element can be selected at random, then the subsequent elements are selected as per the discretion or convenience of the researcher. So there is a controversy with regard to these two statistical methods for selection sample from the population, quota sampling and snowball sampling, whether these two methods are coming under probability sampling or non-probability sampling. Coming to simple random sampling, the condition: population must be finite or small. All the units in the population must be homogeneous, and the researcher should have the source list in his or her hand. So by satisfying these these three conditions, that means if the population must be finite or small, population, all the elements are homogeneous, the researcher should have the source list in his hand. Then we will apply simple random sampling. Coming to stratified random sampling, the population is heterogeneous, and selection of sample from each strata at random. Why? Because the population is heterogeneous. In order to get homogeneity, we divide the entire population into different subgroups called strata. The heterogeneous population can be divided into different parts, different groups called strata. Strata 1, strata 2, strata 3, and strata 4. Then the sample has been selected from each strata proportionately. And sample has been selected from each strata at random also. So in the stratified random sampling itself, we will apply simple random sampling. What is the difference between simple random sampling and stratified random sampling? In the case of simple random sampling, the population is finite or small. Population must be homogeneous. Researcher should have the availability of source list. But in the case of stratified random sampling, the population is heterogeneous. That is why, in order to ensure the homogeneity, we divide the entire population into different groups. Each group is called strata. From each group, we select the sample proportionately at random. So in this case also, application of simple random sampling after the creation of strata from the main population. Again, cluster sampling. The condition, population is very large. And the population is divided again into different groups. Each group is called a cluster. And clusters are homogeneous. Clusters are homogeneous. That means the researcher have an idea about n number of groups in the population. Groups here means cluster. And each cluster should be small representation of the population. Each cluster should be mutually exclusive. And we select n number of clusters at random, and all the units in the cluster will become our sample size. Again, what is the difference between stratified random sampling and cluster sampling? Population heterogeneous. In order to ensure homogeneity, we divide the entire population into different groups. Each group is called strata. From each strata, we select sample proportionately at random, and finally we will get the sample size. Here, the population is very, very large. First condition. It is finite, at the same time it is very large. And researchers should have an idea about how many groups in the population. Then we identify some groups in the population. The group is called cluster. Select as many as cluster from the population at random, and all the units included in the cluster will become our sample, provided the population is very large. Again, multi-stage random sampling. Condition, population is very, very large. Say, for example, customer satisfaction of public and private sector banks in Kerala. Large number of banks are functioning in our state. They have a large number of customer base. Population is very, very large. Our sample size we determined, if we fixed 900. How will you select 900 sample customers from the population consisting of a large number of customers for both the public sector and private sector banks? So in this case, population is very large. Then we select the required number of respondents through different stages. Firstly, we divide Kerala into 3 zones: South, Central, North. From South, we select Trivandrum at random. Central, we selected Ernakulam, North Calicut. Then we select 1 public sector banks at random, and 1 private sector bank at random from the district of Trivandrum in the southern region. In the central region, Ernakulam, we select already the district. Then we select 1 public sector bank and 1 private sector bank. From the Calicut, northern area, we follow the same procedure. This is the first stage. This is the second stage. Again, one branch each from public and private sector bank will be selected from Trivandrum district in the southern area. 1 branch from public and private sector banks from Ernakulam district in the central area. The same procedure is followed in the north area, Calicut. And all the customers of the selected branch of public sector and private sector banks in all the district constituted our target population. And here, the larger population is becoming a targeted population through different stages. How many stages? Stage 1, stage 2, and stage 3. And from the target population, we select the required sample size. The optimum sample has been selected from target population. So finally, the optimum samples were selected from the target population through different stages. This is called multi-stage random sampling. In the case of systematic sampling, the condition population is finite or known to the researcher. First sample is selected at random. Remaining samples were selected at regular intervals. So for instance, women gynecologists working in Kerala 1,500. Our sample size determined to 300. That means 300 women gynecologists have been selected from the population consisting of 1,500. What is the interval here? The interval 1,500 divided by 300, so interval is 5. How will we select the sample? Here the interval is 5. And the first gynecologist has been selected at random, possibly the 10th gynecologist in the list, in the source list. We selected 10 gynecologists. Firstly, who is the second one? The second gynecologist we select will be the 15th gynecologist in the list. What will be the third? The third will be 20th because the interval is 5. You remember one thing, the first unit has been selected at random and remaining units were selected at regular intervals. So basically, in the case of simple random sampling, stratified random sampling, cluster sampling, multi-stage random sampling, systematic random sampling, in all these techniques, when we apply, we select the sample at random. That means every unit in the population has an equal chance of being included in the sample. This is our assumption. This is the application of probability concept at the time of selection of the sample from the population. But no such assumption or condition is applied in the case of non-probability sampling. That means the selection of the sample from the population is fully the discretion or the choice or the judgment of the researcher. There will not be the application of probability at the time of selection of the sample from the population. That is why it is called a non-probability sampling. Then again, what is a sample size determination? Here, sample size determination is the mathematical estimation of the number of subjects or units to be included in a study. We select the optimum number of sample from the population. Then only the data will be appropriate for analysis. If we need the desired level of accuracy, the sample size will be optimum. At the same time, in order to test the hypothesis or validate the hypothesis statistically, the sample size will be optimum. Optimum sample size will be fixed by the researcher and select such sample from the population at random. Then only we can prove our assumption or validate our hypothesis statistically. And what is the consequence of large sample size? The study will be difficult and costly. We need much time for the collection of data from the sample, large sample. Loss of accuracy sometimes. If the sample size is too large, there may be the possibility of loss of accuracy. Therefore, optimum sample size must be determined before the commencement of the study. That is why research design, sample design, and sample design is a part of research design. What type of data required? And how to select the sample from the population? What will be our sample size? Which is the appropriate method for the selection of the sample? All these are decided in advance. That is called a sample design. And sample design is a part of research design. At what stage can sample size be addressed? Calculate the optimal sample size required during the planning stage. That means sample design or research design. Using appropriate approach and information on some parameters. Again, I remember one thing. What we will do in sampling. Sample statistic will be used for predicting the unknown value of the population parameter. Sample study output is used for generalizing the features of the population or through post hoc power analysis at the stage of interpretation of the research. That is something technical. So many errors are there. At the time of selection of sample from the population, random error, systematic error, precision, accuracy. These are something technical. But the researcher has to reduce the effect of such errors for validating our hypothesis or getting valid result for interpretation and generalization. And this is a very, very important section, procedure for calculating sample size. How to fix the sample size? Use of formula. So many formulas are available. But no researcher is getting an idea about why a particular formula is used for the fixation of optimal sample size. At what stage that particular formula has to be applied? So many formulas are available. But one thing we should remember, sample must be the true representative of the population. Sample values will be used for predicting the unknown value of the population parameter. Based on sample study, we generalize the features of the population. Ready-made table, no nomograms. This is a very important method for fixation of sample size, especially in diagnostic research in the medical field. And some of the computer softwares, the latest version of some of the computer softwares like SPSS, Data, Minitab, such softwares have an option to determine the optimal sample size. But in my personal experience, and also some of the best academicians and statisticians suggest some very good formula for the fixation of optimal sample size. And basis for determining the size of sample, precision level, we want to get 100% accuracy through sample study. Specification of level of confidence for minimizing the error. I have already explained so many errors. And likelihood of rejecting the null hypothesis, because in social science, our aim is to reject the null hypothesis. What is the null hypothesis? There is no significant dependence. There is no significant variation. There is no significant relationship between dependent variable and independent variable. No relation. The researcher has an aim of research to prove the positive relation. No need for proving that there is no relationship between dependent variable and independent variable. Through literature review, we select a number of variables classified into dependent and independent. Then we assume certain concrete and sound relationship between dependent variable and independent variable with some hypothesis, and that hypothesis must be validated to prove that positive relationship. So, by fixing the optimum sample size, what is our power? The power of statistics, the likelihood of rejecting null hypothesis. So in social science, the aim of research is to reject the null hypothesis and accept the alternative hypothesis, because the alternative hypothesis clearly mentioned the positive relationship between dependent variable and independent variable. Then, how to get the knowledge about the population? Sometimes the population is heterogeneous, sometimes the population is homogeneous, sometimes the population is finite or infinite, known or unknown. How will the research scholar gets an idea about the population? Through pilot study, pilot survey. That is why pilot study is very, very important in social science research. Use of result of previous survey. The previous survey conducted by somebody else. We can observe such a survey. Intelligent guess, theoretically speaking, it is good. But who can guess intelligently about the parameter? No one can do it. So the best way to know the characteristics of the population is pilot study, preliminary survey. Because in the pilot study itself, we study a part of the population. Selection of respondents for pilot study is not at random sometimes. But selection is due to the choice of the researcher, convenience of the researcher. But what we will do in pilot study? In pilot study, we know the characteristics of the population from where our sample have been drawn for our final study. So pilot survey, pilot study, preliminary study is very, very important, because the researcher will be in a position to know something about the characteristic, the features of the population from where our final sample have been drawn.
Sir,
Audio problem?
the voice is breaking. Yeah,
Hello?
now, yeah, it's clear now.
It's clear. It is clear now.
Yeah.
So in the previous slide, how to get knowledge about the population parameter? Sometimes the population is heterogeneous. Sometimes the population is homogeneous. It is known to the researcher or unknown to the researcher. The only way to know the characteristics of the population during the initial stage of our study is pilot study or pilot survey or preliminary survey. What we will do in pilot study? We select some members or some units from the population with some structured questionnaire or interview schedule and collect data. And based on such information or data, definitely we will have some idea about the characteristic features of the population. From that population, we draw sample for our final study. So here, pilot study result will be used for the determination of optimal sample size with some formula. So how many methods are available for the determination of optimal sample size? The good method is the application of formula. Many formulas are available. And we use appropriate formula against the information from the pilot study, then use such information for the fixation of optimum sample size. And after fixing the optimum sample size by using that formula against the information in the pilot study, we draw our desired sample from the same population. That is why pilot surveys are useful for predicting the features, general features of the population, from where we have to draw our sample for our final study. So finally, sample size determination is one of the most essential components of every research study. The larger the sample size, the higher the degree of accuracy. As the sample size becoming very large, definitely we will get a valid result. More accuracy can be obtained through larger sample study. But it has its own limitation, I have already explained. So optimal sample size can be determined by using different formula. The size of the sample is determined by 4 factors. Optimum sample size is determined by 4 factors. How much sampling error can be tolerated? Normally in social science, we fix 5%. Our confidence level 95%. 95%, the result will be true. We fix a 5% error. That means level of significance. Population size, non-population, finite population. And how varied a population is with respect to the characteristics of interest. We need variability in our observation. When we fix a sample size and collect data for our study, we need some variation. If we have no variation in our data, the interpretation is very, very difficult. Say, for example, the average marks obtained by girl students in a classroom, 55. Average marks obtained by boy students in a classroom, same classroom, 55 again. So these two means have no variation, same mean. Can you compare? No. Because in your data, you have no variation. But the average marks obtained by girl students in a classroom, 55. The average marks obtained by boy students in a classroom, 45. So we can compare and interpret that girl students are much brighter than boy students. Why? Because you have variation in your data. Variation in your mean. If you have no variation in your descriptive statistics for 2 groups, you cannot compare. So that is why the researcher will be in a position to get more variation in your data, then you will have more sample size, optimal sample size. Optimal sample size will give more variation in your data. And the smallest subgroup within the sample for which estimates are needed. Sample size determination. Methods to calculate the sample size are explained in statistical textbook. So many methods are explained in different statistical books for determination of optimal sample size. So many formulas are available. But there may be the possibility of some errors, because small changes in the selected parameters can lead to large difference in the sample size. So when we apply certain formula for the fixation of sample size, definitely there may be the possibility of occurring some errors. Then I will come to the formula, different formula for the fixation of sample size. Cochran formula, the formula developed by Cochran. N0 Z square PQ divided by E square. E is the desired level of precision. We fix the error, sampling error. P is the estimated proportion of the population which has been attributed in question. Q is equal to 1 minus P. Then from the table you have to calculate Z value. So there is a formula. The formula is there. We can find out what is E, what is P, what is Q, what is Z. But remember one thing. There is a table value of Z. And based on that table value and fixation of error, we predict the optimal sample size without having an idea about the characteristic features of the population. And we do not consider the population. We simply take the table value. Another formula, Z score formula. Optimal sample size, necessary sample size. Z score, value of Z, you take it away from table. Square, standard deviation, 1 minus standard deviation, divided by margin of error, say 5% level of significance, square. Again, this formula doesn't consider the population, features of the population. Another approach, sample size distortion. N, that means our optimal sample size, is at alpha plus is at beta square, then sigma square divided by D square. This formula is also not considering the population. This formula is good. Krajis and Morgan model for sampling. We will have a chi-square value, table value. At 1% level of, at the 5% level of significance, table value 3.841. Population size is there because the population must be known to the researcher. Population maybe 5% 0.50. This formula is good, but it has its own limitation. Without considering the population, can we get the value of 50%, 0.50? But in certain circumstances, this is a very good formula. Unlike other formula, it does not consider the population characteristics. But many statisticians suggest this formula. This formula is much better than other formula, because this formula considers the population characteristics from the result of the pilot study. Because we conduct the pilot study firstly, based on the information furnished by respondents in the pilot study, or data analyzed by the and develop some descriptive statistics. Against that value, we apply this formula for the determination of optimal sample size. That is why this is the best method, best formula for the fixation of optimal sample size. Modified data after reliability analysis. When will we conduct the reliability? Reliability statistics can be calculated intrinsic information in the pilot study and used it to determine the sample size by studying the extent of variation in the response. In the sample study, we can have an idea about how much variation of data in the pilot study, or maybe the data in the sample study, or variation of some elements in the population. That is why we conduct the pilot study. It may be stated that sample size is proportional to the level of variation and the assumed level of error of the estimated the population parameter of the study variable. That means through pilot study, we estimate the common features of the population. Because the same population from where we select certain numbers or certain objects or certain members for our pilot study. Whether the selection of the sample from the pilot studies, either simple random sampling or probability sampling or whatever it may be. But when we conduct the pilot study, definitely researchers should have an idea about the common feature of the population. Pilot study data has been analyzed and we calculate certain discrete statistics, which may or may be the value of the population parameters. So, against the data collected through pilot study, we apply this formula for the fixation of our optimum sample size. See the again. N means our optimum sample size. S means standard deviation. Standard deviation calculated from the data collected for the pilot study. D, the standard error of the estimate of the population parameter. And 1.96 is the value, the critical value of Z at a 5% level of significance. Because when we use this particular formula against the data collected in the pilot study, at the time of predicting the features of the, we fix an error, percentage of error. Normally 5% in social science. That means 5% level of significance. So the value 0.05. So this formula is the best formula available for the fixation of optimum sample size against the data collected from the pilot study. And here, I want to demonstrate how to apply this formula through Excel software. So before that, I just show one questionnaire. See this questionnaire. This is an interview schedule for a study, work-life balance of women gynecologists. Work-life balance of women gynecologists in Kerala. What is the population here? Population, all the women gynecologists working in our state in different hospitals, maybe government hospital, private hospital, or any other hospital. The total number of women gynecologists working in our state constitute our population. And in the questionnaire for pilot study, first question name, second question age, below 25, 25 to 35, 36 to 45. So this is a categorical variable. We can't calculate mean, median, or any other discrete statistics.
Sir, please check your network, sir. The sound is unstable now.
Not clear.
Yeah, it's breaking.
Now it is clear.
It's clear.
Now it is clear.
Yeah, it's clear, but it is breaking occasionally.
Some network problem. I think some network problem. Anyway, I will try.
Okay, sir. Okay.
Now it is okay. Biju,
Okay.
now it is okay.
It's okay now. It's okay.
Okay. So this is a questionnaire for the study of work-life balance of women gynecologists. Second question, age, categorical variable, nominal scale. Third question, again nominal scale. Two categories are there. Number of years of experience, 5 categories are there. So here nominal scale is used. Question number 18, do you feel any discomfort in your place of work? 2 categories. Those gynecologists who said yes. Other category, no. And please rank the following reasons. 1 to 12 reasons. So this is an ordinary ranking scale. Question 19. So many variables are to be measured by using different statements. 4 statements were used for the measurement of this variable, bad environment and climate in hospital. Again, 4 statements were used for the measurement of this qualitative variable, no peaceful ambience in hospital. Which scale we use? We use interval scale. 7 for strongly agree, 1 for strongly disagree. When we use interval scale variable for measurement, automatically the qualitative variable becomes quantitative variable. Then we can calculate mean, median, mode, standard deviation, or any other statistics. This is a measurement theory. Once again, bad environment, climate in hospital, no peaceful ambience in hospital, emotional nature of work. These are the qualitative variable that can be measured by using different statements, n number of statements under each qualitative variable. As many statements are to be used for the measurement, that has been decided by the reliability analysis. But if we use interval scale for the measurement of a qualitative variable, automatically the qualitative variable will become quantitative variable. This is what the measurement theory says. So at the time of collection of data in the pilot study, we can calculate the descriptive statistics of all the statements used for the measurement of all the variable. How many statements here are used for the measurement of n number of variables, starting from 19.1 to 19.127, I think. 19.127, yes. So 127 statements were used for the measurement of n number of variables, qualitative variable, on a 7-point scale basis. And in the pilot study, we collect this observation, this data, for all the 127 statements. For all the 127 statements, we collect the responses from the selected gynecologists only for pilot study. Against all the 127 statements, definitely we can apply descriptive statistics. You can calculate mean, you can calculate standard deviation, mode, skewness, whatever it be. You can calculate the descriptive statistics for all the 127 statements used for the measurement of n number of qualitative variable. See, when we collect data from the pilot study by using this questionnaire, definitely we will have a snapshot of the characteristics of the population to which we apply the study. That is a way I already mentioned. Pilot studies is important. See, I select 100 gynecologists for my pilot study. With this questionnaire, against 127 statements used for the measurement of n number of variables, definitely I may have some data against all the 127 statements used for pilot study. The pilot study was 100. I selected 100 gynecologists and collect data for the pilot study with this questionnaire. And against 127 statement, I have the data. See, I enter the data in the Excel spreadsheet. I enter the data in the Excel spreadsheet. See, 100 respondents. 100 respondents. 1 to 100. 1 to 100. 100 respondents. I collect data from them for my pilot study. Against 127 statements. 127 statement row wise. 127. 127 statements were used for the measurement of n number of variables. Responses may be obtained on a 7-point scale basis so that the qualitative variable becomes quantitative variable. 127 statements. So 127 columns. See, then how to apply this formula? I had already explained the importance of that formula. This is a formula. N is equal to 1.96 standard deviation square divided by D. And this formula can be applied against the data collected through pilot study. In the pilot study, we may have some idea about the population from where our actual samples have been drawn for our final study. So against the data, we can apply this formula. In all other formula I had explained, do not consider the population because there was no pilot study. Some table values are there, and based on some table value and fixes or some error and predict the optimal sample size. But here the optimal sample size can be calculated against the data collected through pilot study. That is why this formula is much reliable than any other formula I had already explained. See, I enter the data for all the 127 statement column wise, row wise, 100 samples. 100 gynecologists were selected for our pilot study. Then I calculate mean, firstly, mean. In Excel format, it is very simple. Equals average. Average. Then select the column. Select the column. Mean means mean means average. Then select the column for which we need the average. You observe it, just wait there. Average. Select the column. close the bracket, enter. So here 3.52 is the mean calculated against the first statement. We have 127 statement in my study. Against the first statement, we have the data like this on a 7-point scale basis, and we calculate the mean. How to calculate the mean once again? Is equal to average and select the column and drag it. Select all the observation in the first column. Then bracket and enter. So here we calculate the mean response of the first statement out of the 127 statement, upon which we already got the response of the respondent in the pilot study. Then calculate the mean value of all the 126 statements remaining. All the remaining 126 statements we calculate. See, this is a procedure of the calculation of mean of the response of the pilot study. Calculate mean. It is very simple. Then in the formula, we need standard deviation, SD, equals standard deviation, STDEV, standard deviation. Select the first column again from 1 to 100. 1 to 100. Close the brackets. Enter. So we get the value of standard deviation for the first statement out of the 127 in the pilot study. Then calculate the standard deviation of the remaining 126 statements in the pilot study by dragging like this. So calculate the standard deviation for all the 127 statements. All the 127 statements. So we calculate mean and standard deviation for all the 127 statements in the pilot study. See, all the 127 statements upon which the response may be obtained on a 7-point scale basis. Interval scale is used there for the measurement. Again, then we apply the formula for the fixation of optimal sample size N. Optimal sample size N. And how to apply this formula? What is the formula here? Formula 1.96 standard deviation square divided by D. I had already explained that formula. See, this formula is applied against the data collected through pilot study. And in the Excel format, how it can be applied? Because we have already mean and standard deviation there. What is the level of significance? 5%. Then 5%, what is the Z value? 1.96, table value. At the time of fixation of optimal sample size, the expected error will be 5%. That is what we tell us statistically, equals bracket 1.96, that means value of Z at a 5% level, into standard deviation, standard deviation, bracket close, square here means hat 2 divided by bracket 0.05, that means 5% level of significance. 5% means 0.05 into mean bracket close at 2, that means square. Enter. So the N for the first statement 790, N for the first statement 790. See, calculate mean, calculate standard deviation. Based on mean and standard deviation, we will apply that formula which is more reliable. How it is applied? In Excel is equal to bracket 1.96 into standard deviation already calculated. What is 1.96? Value of Z at the 5% level of significance. 1% level of significance, the value of Z is 2.86. That has been taken from the Z table. Statistical table, it is available. Into standard deviation, square means hat 2 in Excel, divided by 0.05. 0.05 here means 5% level of significance, 0.05 into mean already calculated, square means hat 2 in Excel. Then calculate the N for all the remaining 126 statements. Remaining 126 statements. Okay, so the procedure is over. Once again, calculate mean in Excel for all the 127 statements used in the pilot study. Calculate standard deviation of all the statements, and based on that formula, we apply it in the Excel format and calculate N. See, then observe against which statement we have the highest N. We have 127 statements in the questionnaire for the pilot study. Calculate mean for all the 127 statements and find out which statement has the highest N. See, I think the first statement has the highest N. See, all others are around in and around 200, 100, below 98, 179, 120, 98. So only one statement has the maximum N, 790. So here, practically, we fix the sample size, optimum sample size. The highest N will be the optimum sample size according to this formula. So according to this formula, we observe which statement has the highest N, and in this case, in this experiment, first statement has the highest N, 790. So according to the application of this formula, 790 is the optimum sample size for this study. So this is a way the optimum sample size can be determined by applying this formula, provided this formula considers the general features of the population through pilot study. In the pilot study, we collect some information with a clear-cut questionnaire, and data has been collected. Such data has been analyzed for predicting some features of the population, the actual population, from where our sample has been selected later for the completion of our study. So this formula clearly considers the population parameters through pilot study. So that is why this is the best formula applied for the fixation of optimum sample size for any type of inquiry. Thank you. Thank you very much. If you have any doubt, definitely I'll clear it. Please. Bichu? Bichu?
Yes, sir. Yes.
Yes.
Sir, Anne Mary and Anjali will ask the doubts for the participants now. Because
Yes.
they are the coordinators for today.
Thank you so much, sir. Thank you, sir, for that insightful session. Now the floor is open for further discussion. If any participant has any query, you may post them in the chat box. We'll ask them on your behalf, or you may unmute yourself and clear your doubts directly.
Ask your question through chat. Type the message in the chat box.
There are many questions in the chat box. Coordinators, please ask.
Sir?
One by one, you can ask.
Sir, there's a question from Gopesh. He's asking, most of the studies and authors reveal that 380 or nearest 380 is the adequate number of sample size in research. So what is the criteria for fixing 380 line to fix the sample size?
790 sample size.
790. Okay.
Once again, you ask.
He simply wants to know if there is what is the criteria for fixing 380 sample size, because it is most commonly seen in most of the research works. That's why he is asking that.
What is the criteria for?
Fixing 380. 380.
380.
Yes, sir.
So in that case, the optimum sample size 790. See, the highest n you observe for all the 127 statements. Here, the first statement has the highest n, 790. So 790 is the optimum sample size. Because when we fix the sample size at 790, definitely our original data will have certain variability. You can interpret the result in a better way because the data has enough variation to prove your or validate your hypothesis. So that is why this formula is more reliable. Yes.
Oh, okay, sir. Then there's another question from
pilot study along with the. So another question I noticed: can we use the same data along of pilot study along with the original study? No. Pilot study data has been used for applying the reliability analysis, or sometimes validate our questionnaire, or fixation of sample size. This data will not be used for our original study. Then any other question?
Thank you, sir.
Please type
sir,
it.
there's another question from Indu Kamal. She wants to know, sir, for determining the optimum sample size, why a particular formula is used and what stage can we use that?
So many formulas are there. I had already explained. But in all these formula, we use the values from the statistical table. But none of these formulas are not applied against the information collected through pilot study. What is the importance of pilot study? It's a preliminary survey, the preliminary study about the characteristics of the population, how the population behaves, what is the specific characteristics of the population, specific features of the population. For that purpose, we conduct the pilot study. So pilot study data are much reliable than those formula which are based on table value. So that is why this formula is much better than any other formula I had already explained, because this formula considers the population through pilot study.
Then there's another question from Amritambiga. So can you please explain nominal, ordinal, ratio, and interval scales?
See, normally when we construct a questionnaire for our study, we use nominal scale, categorical variable, ordinal scale, ordinal ranking, interval scale for measurement, especially for against qualitative variable, and ratio scale that may not be used in social science research. But ratio scale can be used in medical research or agriculture research. Normally we use nominal, ordinal, ordinal ranking, then interval scale in social science research. So that is why measurement is one of the very, very important module in research methodology. Any other question?
Sir, how to determine the sample size for a study that is completely qualitative? For example, if the study method is only in-depth interviewing.
This is a very good question. Qualitative study, how to fix the sample size? See, one researcher from history has undertaken a study. The ruling of Akbar in India. The title is like this. So here I want to ask one question. Is he measure something? If you measure something either through descriptive research, empirical research, or even exploratory research, that measurement needs some scaling. He proves something based on data. So in that case, data has been collected from different sources. Data has been collected through sample survey from the population. If you have finite population or even infinite population from where we draw sample, then we can fix the sample size. If the quantitative study require a survey, definitely we will have the optimal sample size. Then?
So there's a question from Anandu. Can you use overall mean and standard deviation for determining the sample size using the formula?
Actually, what we did today, we calculate mean, standard deviation of the information or data collected through pilot study. Then we observe the unknown value of the population. We have mean like this. We have standard deviation here. We fix a 5% error, level of significance. That means 95% our confidence that this value is similar to the value of population mean. That is why we fix a 5% level of significance. 95% we are confident that this mean, the mean of the sample data, is almost similar to the mean of the population. And that is why this formula is much better than any other formula explained earlier.
Then, sir, there's a question from Sumi J. Sir, please explain post hoc power analysis.
So power analysis is basically, I have already explained, such all of these other formulas are based on statistical table. All these formula doesn't consider the population, the characteristics of the population. So in the power analysis, we predict that our null hypothesis has to be rejected. So the power has been estimated. What is our power? The power to reject the null hypothesis, and what percentage we are confident that our null hypothesis has to be rejected. Because in social science, our aim is to accept the null, the alternative hypothesis. So based on such power, we predict the optimal sample size. Any other question?
Yes, sir, there's a question from Thomas Kane. Sir, is there any model number for sample size and for pilot study?
Normally in the pilot study, we take a 50 to 100 sample from the population by choice or convenience. Anyway, the sample drawn from the population for the pilot study clearly the representative of the population for our final study. So 50 to 100 is enough, maximum.
So the same question was asked by Sriraj also. Then there's another question from Nayana Prabhash. Can you state the name or who proposed the last sample size determination equation, explained, or any reference material regarding the third equation?
Definitely. So many books are available. Tomorrow I will give the list of books, especially the books clearly mention the title sampling. That module has many books available. I will give the complete list to coordinator Biju, and he will give all the list to all the participants.
So there's one last question from Ashwati S. Sir, is there any classification like proportionate and non-proportionate stratified sampling?
Proportionate and non-proportionate in the stratified random sampling, because in the stratified random sampling, the population is heterogeneous. In order to get to homogeneity, we divide the entire population to different groups. Each group is called a strata. From each strata, we select a required number of sample proportionately. Because in the first strata, 100 units. Second strata, 200 units. So the ratio is 1:2. So sample has been drawn from each strata proportionately. Then.
Sir, there's one last question again. It's from Anjali S. What exactly does multi-stage random sampling mean?
What exactly multi-stage random sampling? Condition population is very large. From the large population, we will have a targeted population created through different stages. From the targeted population, we select the required sample size. Then
these are all the questions that were posted in the chat box. If anybody has any more doubts, you may unmute and you may ask directly. So I don't think so anybody has any more doubts. Thank you so much, sir, for that informative and enlightening session.
Thank you very much.
I'm pretty sure all the knowledge that you imparted today by combining the conceptual facts and the practical examples will be useful to all the participants in their future research endeavors. Now, I would like to invite Ms. Anjali B., Research Scholar of our department, to propose vote of thanks.
Good evening, all. Honorable Professor Dr. P. N. Harikumar, respected faculties and all participants. It's my privilege to have been asked to propose a vote of thanks on this occasion. Today's session is about sample design and sampling technique, and Sir discussed about sample, types of sampling methods, and give us a detailed description about sample size determination. It was an interactive and informative session. I, on behalf of the Researchers Forum, Department of Commerce, express a heartfelt thanks to Dr. P. N. Harikumar. Thank you, sir. Next, I extend our sincere gratitude to Dr. Biju T, the coordinator of the webinar. I would like to thank all other faculty members and the representatives of the Researchers Forum and Alumni Association. Last but not the least, I thank all our participants for their effective participation. Thank you all.
Thank you. Thank you very much.
Thank you, Hari sir, once again. And thank you, and as well as Anjali, for your nice work of coordination. So see you next day at 6 o'clock itself. Dr. Kevin will be with us.
Thank you, sir. Thank you so much.